See, now slowly we are entering into the different. So some students will write this one, and some student will write this one. So what is the difference? So there should be something, okay, that we are going to analyze now. Now, y equal to a sine kx minus omega t. So let's go for initial condition. We know the idea of phase in SHM, no, that we are going to put t equal to 0 at t equal to 0. So what is the equation? A sine kx. So we'll plot the shape of the rope at t equal to 0. So therefore this will be, now once again, what is y-x graph will give shape of the rope at any time t. That's all, no? Actually we had a discussion. Okay, this is amplitude plus a minus a. This is y. This is x. Okay, I think I'm. This is at t equals 0 is what I plotted. I'm very sure. What is that? Put t equal to 0. What you get? Y equal to a sine kx. As x increases, y should increase. No, for cosine function. Trigonometry. Go back to trigonometry or functions. How to plot a curve if you have equation. That is what I'm applying here. No. So as x increases, the value of y will increase. Maximum plus a. So sir, how you are plotting this function? What is k? K equal to 2 pi by lambda. Then you can go for that. Okay, I agree this. I think that there's no doubt for this one. That t equals 0, the shape of the rope will be like this. Then in what action the wave is propagating? Look at this one. So let's do one thing. If I differentiate this, what do I get? The particle velocity, Vp, should be equal to minus a omega cos kx minus omega t. Put t equal to 0. If you put t equal to 0, so what is the equation we'll get it? Put t equal to 0. Vp is equal to put x equal to 0 minus a omega. So the point which is at x equals 0, it should have velocity in what direction? Should be downward, no? I think this is what the basics what we have. And we know some idea. What is that? The wave is propagating in what direction? Towards right. Then how this point will be moving like this? Okay, great. I think I'm correct here. So no. The point which is at x equals 0, it is having maximum speed, no? So can we plot the wave like a y-x graph? This is the rope. I think. Can we plot even the speed as a function of x? I think that is not needed. If you want later part will, so you'll get confused. Just I wanted only the meaning of this. So what is the meaning of this one is at t equals 0, if the shape of the rope is like this, then you should write equation of this kind. I know what to do for this. I will pull it down. This one will go for. And this is very important. You get often confusion for students are like, what is the meaning of this? There's nothing, just it said depends upon the phase. No. Y equal to a sine. Okay, first we'll start with the mathematics, and then I'll come to the plotting of curve. At t equal to 0, or first we'll find out the speed also. This will be a omega cos omega t minus kx. Then at t equal to 0, then x equal to t equal to 0, a omega cos minus k. So this will be a omega cos kx. This is at t equal to 0. So how to get the shape of the rope? Yeah, now we'll. So look at this. As x increases, y will increase in negative direction. We will try to justify our answers. Okay, this is the plus a minus a. This is y. This is x. What action the wave? Still the wave is propagating in positive direction. I'm interested in this point. Can you say anybody in what direction the particle should be moving? Should be upward, no? Should be upward. At that instant, we are discussing at that instant, at t equal to 0, the shape of the rope. This is a rope. That's all. Okay, got the idea, no? This is like a, there's a meaning of writing this one. Tell me in both the cases, in what direction the wave is propagating? Towards right only. Sir, how do you can say? What is the formula? Wave speed v equal to minus of coefficient of t by, substitute here to substitute with sign, coefficient of x. Coefficient of t is how much? Plus omega. Quotient of x minus k. I'm getting minus of minus plus. So what is the wave speed? I got positive. Positive means moving towards right. Getting the idea now? So how do you can say the wave is propagating towards right means I have formula. Substitute with sign here. You have to substitute here the quantities with sign. So here we took help of this one. You can see omega. Here quotient of t. I'll just shade it because almost there's a very fundamental one. The quotient of x is minus k. So that it will flash for you. Okay, what is the use of this particular formula? Got the idea? This will be. So now I think let's not bother very much what is the meaning of omega t minus kx, omega kx minus omega t. Both the waves are moving towards right only. It's all about at t equals 0. What is the shape of the rope? Okay, I agree this. Okay, now next one, y is equal to, okay, if a students write like this, so let me differentiate. This will be a omega cos omega t plus kx at t equal to 0, y equal to a sine kx. Speed of this will be a omega cos kx. Put t equal to 0. Then in what direction the wave should propagate? Anybody? What direction the wave should propagate? Left or right? Left, no? Okay, good. Yeah, it should be left. The wave should propagate towards left. Okay, the points on a rope, how do they move? Now, how to decide the point at x equals 0? Put x equals 0, it is having velocity, so this will be moving up. So this is at, this is the x, and what we have plotted is at t equal to 0. Okay, now, so again, the omega t plus kx or omega t minus kx, it makes a difference here. Sir, how do you can say they should be moving up? We know the wave is moving towards left. Then what is the slope here? Positive. According to formula, Vp equal to minus V into slope. Apply that, you get this velocity positive. Substitute V with sign there. Okay, so you can determine the speed of any point on a rope. How the energy will flow towards left. How the points on the rope, they'll vibrate vertical. That's why there's a transverse wave. And what is this? It's not a curve. It's a rope itself. The rope will be in the form of sine wave when it propagates, when you wave your arm continuously up and down. So there's an advantage for us. If you just give only one jerk like this, then a pulse. If you wave your arm continuously, you'll get a sine wave. The shape of the rope itself will be a sine wave. What is the lambda here? What is the lambda? Where I have to share such lambda? The distance between 2 points that will have same phase. I think this should be the lambda. Okay, I think we have yesterday's discussion. The distance between 2 points on a rope which will have same phase. So these two are having same phase, or these two are having same phase. These two are having same phase, or these two are having same phase. I think now some concrete idea you are having. Okay, how to write these equations. Now if it is a kx plus omega t, any difference? A student, instead of writing, you will write y equal to a sine kx plus omega t. I think doesn't make difference, no? Omega t plus kx or kx plus omega t, things are same. Got the idea? This one? Okay, now we'll explore the cos. What do you mean by cos function? I'll differentiate. This will be a omega sine kx minus omega t. I think, okay, everything t equals 0. Next function. Yeah. The particle speed is given by this one. Derivative of cos will be minus sine, and here negative, so this will be positive. So a omega sine kx minus omega t. Okay, look it now. This is okay. Let's try to plot the shape of the curve, shape of the rope at t equals. What direction it is propagating? Towards right again. No, at t equals 0. We need information of t equals 0. No. So at t equal to 0, put t equals 0. So y equal to a cos kx. Put t equals 0, a omega sine kx. Okay, I think now let's leave it. Looking at this speed and also this one. Put x equals 0, you get plus a. Plus a is available. So therefore, what direction the wave is propagating? Again towards right. This is at t equals 0. Is it justified? So shape of the rope will be like this only. I think the equation itself says no, put x equal to 0, y equal to plus a. Put x equal to lambda by 2. What is k? K further. If you are interested, no, you should explore like this. Huh? Mere guess need not. This is a further. Put x equal to 0 plus a. Put x equal to lambda by 4. Lambda by 4, how much you'll get it? Pi by 2, cos pi by 2 should be 0. This point is what? Lambda by 4. This point is what? Lambda by 2. This point is what? 3 lambda by 4. This is lambda. This is 5 lambda by 4. This is 6 lambda by 4, 3 lambda by 2. This is 7 lambda by 4. This is 2 lambda. Getting some idea? No guesswork. We have enough of mathematics. Actually, uh, you know trigonometry. That's why I'm writing. Otherwise, what a student should do? You should assume the various values of x equal to 0, x equal to lambda by 8, or still more, you break up lambda by 16, x equal to lambda by 16, like a 2 lambda by 16, 3 lambda by 16. The more, if the interval is very small, the curve will be exact. Plotting graphs, I think what all you learn mathematics, you should know how to use like this. There's a purpose of doing trigonometry. Trigonometry is not solving question answer. For every equation, you're supposed to plot a graph. You're not doing that. And it has become a dry. There's a problem. In mathematics, no, any equation, what you see, you should plot a curve. Then only what happens, the concept hidden will be very easy. But what's happening? Question, we'll end up with answer. Why you are studying that question? Question is there, sir, we are getting the answer. But the mathematics is not meant for solving questions. For every equation, what happens, you're supposed to plot a curve. The interpretation of curve is very important. Where do I use this? So you just open some any engineering textbook, no, you see all the application. So what is the use of trigonometry? I can say definitely very much in waves and sound. Okay, got the idea? So what is x? What you should take x? X should be in terms of lambda. Okay, I agree this. So in the beginning only, I would have told you'll get confused. So and we know what is one lambda. This two, this is one lambda, no? This is two lambda. Y equal to a cos omega t minus kx. Let's explore that also. Y equal to a cos omega t minus kx here. No, we'll differentiate this. Speed of particle will be minus a omega minus a omega sine omega t minus kx. Okay, now what is the thing at t equals 0? At t equals 0, so this will be y equal to Cos of minus theta will be cos theta. The time being, let me write it. So speed of particle will be minus a omega. Look at this one now. So let's go for the plotting of curve. What shall I do now? So is it justified? Again, sir, okay, say same rope, same shape. Okay, look at now. And what are the points? So this is the lambda by 4, lambda by 2, 3 lambda by 2, 2 lambda. At x equal to 0, y should be plus c. At x equal to lambda by 4, it should be 0. Okay, I think justified. Cos of minus theta will be cos theta. I need not to bother. Or if you want, you write a cos kx. But we know what is the state of particle here. At x equals 0, the particle should be at rest, no? According to this, the speed. Then as x increases, the sine function should increase. The sine function should increase. If sine as x increases, sine function will increase. As sine function increases, the speed of particle also will increase. I think I'm very sure like the wave is propagating here. So then how the points on a rope at this instant will be moving. Okay, I agree this. So there's a justification. See, like we can't just end up with some mathematics and conclude. We'll take help of the speed and we'll justify our answer. You see that as x increases, speed should increase. You know sine function. As x increases, the sine function will increase. The speed also will increase. We know the speed here 0 here maximum. So the shape of the rope in fact will be like this only. Okay, omega t minus kx. So earlier what we plotted, kx minus omega t minus kx. Okay, here also, sir, like, can you show about the speed? Yes, it will be the same idea. Okay, I think very minutely we should always where we have to jump in plotting the shape of the rope. That's all. Finish your first. So got the idea now? So what is the meaning of all these things? Okay, let me introduce the phase of a wave. four lines. Yeah. At t equals 0, the wave is propagating towards right. This is x, and this is a rope. Shape of the rope at t equals 0, it is like this. And the wave is propagating toward, is asking us to write the equation. Okay, I think let's a bit directly. Now, instead of giving equation, what he did, he has given us the shape of the rope. This is y. So yx graph, what it will give? Shape of the rope at any time t. So how to decide this? Okay, I'll do one thing. I'll take help of the velocity of particles. In what direction the waves are towards right now? So how do this point? They should move like this. Just for a convenient purpose, huh? The different points on a rope should be moving like this. At t equals 0. Not every time. Okay, not at every instant of time. At t equals 0, it will be like this. This is a by 2. Okay, now what should be the at t equal to 0 in the velocity? What happens if you substitute? You should get negative. I think these are all things which we have to take care. That's all. No, at t equals 0, the point on a rope at x equals 0, t equals 0, the point on rope will have velocity downward. There's also we have to take care here. Let's get into the basic idea. So there is some phase. So shall we write sine kx minus omega t or omega t minus kx? So at t equals 0, as x increases, y will increase, no? Are you noticing? At t equals 0, as x increases, the y will increase. So therefore, this should be. And there is a phase. Now let's come for this one. At t equals 0 and x equals 0. So y equal to a sine 0 minus 0 plus 5. What is the value of y? Y is equal to a by 2, a sine 5. So the phi is pi by 6. This is the initial phase. Okay, well, after getting this, we'll differentiate. If I differentiate, I'll get minus a omega cos kx minus omega t plus 5. At t equals 0, x equals 0. Again, minus a omega cos 5. So what is the phase angle? Pi by 6. So cos 30 will be minus a omega root 3 by 2. Cos of 30 degrees will be root 3 by 2. And we are very sure is what, like the particle is not at mean position, no, to have maximum. If it were at mean position, maximum speed. I think just fine. No, we got negative one. You see that we know that this particle will be moving down. Getting the idea? No. So is it justified? So what is our equation of SHM? Our equation of SHM will be, or so like a wave equation will be y equal to a sine. Okay, this is our answer. This is a wave equation. So what is this? Just you extend this one. This is what that phase. That's all. We can cross check also. This should not be something more than 90 degree, no? This was the phase of SHM. Looking at not velocity, just looking at this distance. So this was the phase of SHM. You just add up there. That'll be over. Got the idea? This will be. So these are some mathematical things what happen regarding the phase of an SHM. Anybody, if you have a doubt, say what we have to do. We have to take care about even the sign also. Always I'm taking help of the velocity also, so that we'll be in a better position whether we did mathematically right or wrong. Okay, there's a rope, shape of the rope at t equals 0. It's not a curve. It's a rope itself will be in this particular shape. Okay, same thing, same conditions. Let me bring. This will be more useful for student. Okay, now this is the wave is propagating like this. I myself I'm giving, and this is at t equal to 0. The shape of the rope is this much. We have to write the wave equation for this. The wave is propagating towards right at t equals 0. The shape of the rope is as given. I'll extend this. See what type of science now we have. We have a science where we want some sort of equation for that question, and we have to carry forward. This is what not science. So if you look at the textbook, see textbook cannot go to the extreme level. Then what when waves and sound only they have to print 1,000 pages. So they give one example. That's all. At the most two example. Then they expect that with that the students will manage. And what students will think, okay, what is the content in textbook? That is sufficient. No, the content in textbook is only 10%. Again, you have to explore. They may explain one, two cases. The remaining other 10, 15 cases, the student has to analyze. So this is what missing. So students, they say like, sir, I revised the total textbook. So what you did, what is there in textbook? Just you are remembering. So if you just open textbook, no, you have this particular thing. He has given this, or say for this he has explained. Next one, cause he has explained. And students will think, okay, these two cases is enough. You should explore, no? Why can't be it is like this? Why can't be like this? Why can't be like this? This is what missing. So students, what is there in textbook? You'll confine to only that much. Knowledge will not flow. How knowledge will come? You have to analyze several situations, no, very complex. Then what when clarity will come? So mere content in textbook, what is there? Again, it's a 10%. Okay, now how to get the phase? Okay, let's get into the velocity parameter. We know that this point will be moving up. Okay, some idea we know. Vp equal to minus v into slope. From that we have, so at t equals 0, what is the y? Y is a by 2. You can see clearly. And the amplitude is plus a. What shall I do to write the equation? What direction the wave is propagating? This one. And look at this one. As x increases, what's happening to y? The y is decreasing. And also as x increases, the speed of the wave, the speed of these points also decreasing. So we have to keep all these things in mind. We have to generate equation. I too don't know. I'm just trying experimentally. I'll write it. Y equal to a sine. Put x equal to t equal to 0. Put x equal to 0. T equal to 0. We'll get y equal to a sine phi. And what is y? Y is a by 2. If we solve it, we'll get pi by 6. No. But we know this is more than pi by 6 because this itself will be pi by 2. This total phase, how much will be pi? Then there should be something more than pi by 2, no? At least. This total phase will be phi. Am I right? This total phase will be pi radian. So how much this will be? This phase will be 90. So what all phase angle will calculate should be more than 90. Anybody suggest what you can do here? Then if I differentiate this, what do I get? A minus A omega minus A omega cos kx minus omega t plus 1. Put t equals 0, x equal to 0, cos of. I should get positive, no? The speed is, the velocity is positive. So cos 30 degree will be positive. So something I need more phase, no? So that cos will become negative, then this will become positive. So definitely this phase angle should be more than pi by 2 and less than pi. But how to get that value? Or shall we write omega t minus kx? Anybody? I think your trigonometry should come into picture rather than physics teacher. Like a physics teacher knows only waves and sound, how to draw a rope, that's all. As x increases, y will decrease. Okay, we have phase angle. Okay, somebody is suggesting. I'll write it. I'll write it, no problem. Omega t minus kx plus phi. Okay, no problem. So differentiating this, a omega cos omega t minus kx plus phi. At t equals 0, we'll directly go for at t equals 0. At t equals 0, the condition will be y equal to a sine here at t equals 0. So which student is right? The wave is pointing towards right. There's no problem with the wave, this particular, the wave is pointing towards right. So who is right? Is this student or this student? First of all, we don't know phase angle. That has to be determined again. I'm very sure the angle should be less than pi, greater than pi by 2. Am I right? At least I'm very sure. But if you substitute x equal to 0, what is the value of y? Y will be how much? A by 2. Then I'll get phase angle pi by 6. But I'm very sure that it should lie somewhere between 90 and 180 degrees. Okay, this one, the mathematics, what we know with that we are analyzing. So here, these are the some, you can say, difficulties what a student will face in that situation. So now we know that this particular speed of particle. So when you substitute this particular thing, so we know the speed is positive, no? So there's a cross check. So I'll put x equals 0, cos of pi by 6, I'll get negative. But actually it's a positive. So therefore, some problem is there with the phase angle, what we calculate. So it is in fact, the phase angle is pi minus pi by 6. Not pi by 6. It should be pi minus pi by 6. So if they give value, here I don't have the value of x. If they give this particular values, no, here, the value of x in terms of lambda, if I have this, by substituting that, what happen rather than substituting, so here I'll substitute some other values here, which is available. When I substitute those values of x, which is available here, what is the value of x here? I don't know. If I give that information of value of x at this point, no, or at this point or anywhere, so that I'll substitute. Then when I solve it, I will end up the phase angle something like this here. So how do you can say pi by 6? I'm very sure. Put x equals 0, what you get? A by 2. The phase angle is pi by 6. So pi minus pi. This is the phase angle. But I'll be giving you some wrong information if I say this is the phase. Actually, this is a phase only. But this phase angle should be less than pi, more than pi by 2. What we are getting is put x equals 0, pi by 6 will come. If you put x equals 0, instead of substituting x equals 0, you should substitute these values somewhere here. These values. So I don't have that values, no, just explaining things in this particular way. Okay, got this one. So the phase angle is pi by, now I can justify my answer. Huh? Put this phase angle pi by 6. Put x equals 0. Cos of 5 pi by 6. Positive or negative? Anybody? At x equals 0. This I will rule out. Okay, let on this one. Okay, Vp equal to minus a cos. Anybody? Cos pi by 5 pi by 6. Cos 5 pi by 6 minus root 3 by 2. Okay, justified. So always that velocity equation will help us whether we are right or wrong. That's what I brought here. If you write only pi by 6, tell me what is the problem? You get negative, but we know the speed of particle at x equals 0 should be positive upward. Like this, I think when you start solving some problems where if they give values of x, no, it'll be very easy for you. Okay, got the idea? So these are the some, I think, sir, why can't this be right? Why can't this be right? Put x equal to 0, a sine 5 pi by 6. Okay, there's no problem with this. Put x equal to 0. A omega cos particular thing. But again, uh, as x increases, so at t equals 0, you look at this particular thing. At t, this phase angle is there. Now what happened? You have to put the values of x equal to lambda by 8, lambda by 16, lambda by 8, 3 lambda by 16, 4 lambda, like this. You keep on put it, and you have to trace the curve. If it satisfies this, then this will be correct. It should be. Okay, no, I'm more interested on this particular, the idea of the phase. Okay, very few problems are there. So just a student, what happen if he gets a shape of the rope like this? Okay, the equation has to be written in this way. Okay, this is a background what we had, the idea of phase. So let's focus some problems on the